Hello, this is David Birch at Star Path School of Navigation in Seattle with a note to illustrate an article that will be posted. The link to it will be posted in the discussion. But it's an unusual case I just noticed of the pressure tendency being able to forecast a wind direction fill in. And that I haven't seen it happen that close before, especially with such crude pressure data. But it's interesting. Situation is here. We have a boat that has to go into Victoria. This is actually the first leg of the race to Alaska, and the boat. This is a Mad Dog team. Mad Dog come over here. Very fast, 18 knots are coming across here, but then the wind just totally died. Actually, as predicted in the models. But so the wind died here, and so as far as I know, they haven't actually finished yet. But as far as I know, they're pedaling the boat right at this moment with no wind. So at that point, you could wonder what's going to happen, although there is a forecast. Actually, the forecast called for strong southeasterlies, so that was actually wrong, at least wrong for the moment. But then you could go to these two reports, and these are Canadian observations, and this is Esquimalt, which is right here. That's Victoria Harbor, and they use kilopascals for some reason, and so we only get the pressure to 1014. So that's 1014 millibars and rising. 1014 millibars and rising. It's nice to know this to a tenth, actually. And then over here is then Discovery Island, which is just a little bit off the road there. Okay, I got interrupted for a minute, but here we see the pressure over here, and these 2 points are very close together. That may be 5 miles or something. These two are only 5 miles apart. So it's a little bit unusual to see this kind of pressure change. That's like a whole millibar in that distance. It's just... their meters aren't, well, I don't know if I should even do this. Their pressure meters have got to be wrong. But anyway, let me illustrate the point. So this is 1014 millibars and rising over here at this west end. This is 1013 and falling at this end. So that means that the pressure gradient from across here is increasing. So the wind, and we know right now, there should, like if this really were 1014 and 1013, there would be a huge wind blowing here from the west, but there isn't. But the interesting thing, so it's more interesting. Here's the thing. Even though one of these pressures is totally wrong, I mean wrong by a millibar or so, the tendency, the trend, the tendency, these arrows are correct. It's easy to get the tendency right, even though you have the absolute pressure wrong. So that makes a better example than I even guessed. So, but here are the pressures. Let's say these are identical, which they have to be, right? The real world is there's no wind here right now at this point. At 8 o'clock, or this is like 8 o'clock, 8:30, there's no wind. It's basically calm. So these two pressures have to be the same. But notice that even on the tenth of a millibar scale, these meters are accurate. These barometers, electronic barometers, are accurate for reading the trend. So this one's rising and this one's falling. And the fact that they're a little bit, the pressure itself is wrong doesn't matter. So what it means is if they're the same, we know these are the same, not different like they show. But we know that this one's increasing, and this pressure at this end over here is increasing, and this one's decreasing. So it could be like 1013.7 going to 0.8, and this could be 1013.7 going to 1013.6. But the main thing is dropping. The trend is dropping. So that means the wind should fill in from the west. The pressure is building up. It's going to be higher at the west than here. So now we can come back and look and see here what a forecast would be. And, whoops, what happened? Okay, well, I don't know what happened there. Okay, well, okay, there we go. So here is then, now here's 9 o'clock, 8 o'clock, they were somewhere here. This is 9 o'clock, and this is the high resolution. This is a forecast. It's about 3 hours old, which is newest we can get. But this is a forecast for the winds in this area from the high resolution rapid refresh model. So at 9 o'clock we have this, and look, it says here that there's some amount of wind. we can see what it really thinks there is. It thinks there's 6 knots of wind, 6 or 7 knots of wind, but there is not 6 or 7 knots of wind right now. It's actually basically calm. So but let's just look at the trend of the wind. All right, so now I go up. There's the 10 o'clock. Okay, let me go back. There is a 9 o'clock, and you see they're showing it north. Right now it's north 0, and then we go up. There it goes now to the northeast. Now it goes to the south. You see it's veering around, and look at that. Now it's 15 out of the west. And so here's 20 down here, you see. So sure enough, but that was like 9 o'clock. That took 6 hours. It took 6 hours for this kind of run from here into here. That's not going to be very helpful for anything. But for the general idea of looking at 2 different pressures at 2 different places and then predicting how the wind is going to change or how build up from a calm, that's a really valuable thing and shows you the virtue of using barometers in your navigation.